Welcome back. So in this module, we are going to look at something called Hive. So let me cover what we are going to cover in Hive. First of all, we are going to cover the basic architecture of Hive, how Hive works, and how you kind of make use of Hive. And then finally, we are going to look at some of the operations that you can commonly use in Hive and the demos. So let's get started. So what is Hive? So Hive is essentially a very lightweight data warehousing layer on top of Hadoop. Now you saw Hadoop is comprised of essentially two parts in the previous modules. You have the storage. In case of HDInsight, the storage layer is Azure Blob Store. And then you have a MapReduce layer on top of it. Now, you saw some samples of MapReduce code. In fact, Bill ran the hello world of MapReduce that's coded in Java. Then you have the .NET code for mapper, reducer, and so on, so that you saw. Now, for every data analyst, either coding in Java or .NET is not what they wake up every day or get excited to wake up every day for. So there's an easier way to do MapReduce. And it's so easy because it's SQL. Essentially, Hive maps very closely to the SQL syntax. So that's its one huge value proposition. And that's why in some estimates in Facebook and at Yahoo, 60 to 70% of the Hadoop jobs written are in Hive or Pig. Pig is another language, data flow language, which abstracts the complexity of MapReduce, and thereby it's much simpler to program in. Now, as you'd imagine, because Hive is very similar to SQL, it makes sense that you would have something like a ODBC driver for Hive, which what that basically does is that if your applications is using ODBC or can use ODBC, now they can fire Hive queries through ODBCs and get data from Hadoop or run queries on Hadoop, which is a huge win. The other aspect is that, of course, you want to interactively query Hive, right? Like in SQL Server Query Analyzer, you can type in a SQL query. Similarly, Hive also has a HiveQL client where you can interactively fire Hive queries, and then a MapReduce job auto-magically gets generated and executed, and the results come back. Now, you might wonder that, hey, okay, I can run queries on data stored in as text files like we saw, like Bill did in previous demos. Where is the schema in all this? So the schema is something which you create before you can fire the Hive queries. So the schema, if you look at the slide, there is this box called metastore, right? So that's where, which is by the way just a database. In case of HDInsight, it's actually Azure SQL database where the metastore is hosted. Now, once you create the schema, it stores that schema in that metastore, but it doesn't do any change to the raw data. So if you want to run raw MapReduce jobs on the data sitting on the Azure Blob Store, you can still perfectly able to do that. What's even better is that you can create multiple schema on the same set of files, because again, the data doesn't get changed. It's more like views. The schema that you're creating is more like views on top of the raw data. Now, once you have done that, created that schema, then as I discussed before, you can fire this HiveQL or Hive query language query, and then it automatically generates the MapReduce job and runs it. So that's in short what Hive is. Once Bill shows the demos, it will be much more clearer what it is. But let's look at what are some things that we can do. Now, like in any relational data store, you have the basic operations like create table. Essentially, again, you are creating the schema for the table on the raw data, and that table schema gets stored into the meta store, and then you want to import data into Hive table. Now, while creating the table, you can directly point to a folder or a directory construct on top of Azure Blob Store, and it can all that data will be used during the query. Or you can say that copy the or pull in the data from another folder and create a copy of those data files for my Hive table. And once you're done with that, once you have the underlying data, that's when you can start querying it. Now with that, the proof of the pudding is in the eating, right? So here, Bill.
It's all in the demo, I tell you. Okay, my goal with this demo is to make it clear to you that if you know Transact SQL or any other SQL dialect, that HiveQL is going to look very familiar to you. So I'm going to run through a set of scenarios where we'll go through some basic select statement syntax and kind of show you that similarity so that you can quickly get up to speed with HiveQL. Okay, to start out with, we're going to go back to our interactive console. And up to this time, we've been using the interactive JavaScript console. Over here is this thing called Hive. And by clicking on Hive, what this allows us to do is run Hive statements within our editor. Inside the lower part here allows me to copy and paste in Hive commands. And so the first thing I'm going to do is we're going to go ahead and create a table off our MapReduce result. Now, because I have my text editor here and it's going to be a little easier to read what's going on, I'm going to go zoom in and show you what we're going to do. First thing we're going to do is, you notice here the create table syntax looks very similar to Transact SQL. One key difference is the use of the word external here. And what external does is it allows you to say, keep the data right where it's at on the storage so that it doesn't actually go into the cluster, so that when you finish doing your queries and things like that, that data still resides in place. The column definitions are very similar to Transact SQL, though the data types are a little different, but string and bar char are essentially the same. And so we have our state, county, age group, and total population defined as strings. The other thing that we're doing is we're telling it that our text file is delimited by columns. And so that way Hive, when it deals with the data and when it's actually sitting on disk, is saying it's comma separated. And then finally, we're saying store it as a text file to our particular Azure storage. Now, text file is one of two basic options when you're working with Hive tables. Text file is by far the easiest one to use. It's essentially, based on the definition here, comma separated. But you also have sequence data or sequence file type, which is stored in a binary format and gives you some optimization on the table when you're doing the queries and in loading data. So if go back now to our editor here, I'm going to take this command. And Hive commands, similar to Transact SQL commands, terminate with the semicolon. I'm going to go ahead and now paste this into the editor. And again, the location is our container working with our storage account, and then indicate the path where we want the data. So I'll go ahead and evaluate. And so behind the scenes, this is actually doing a little MapReduce job to actually
Actually
create the
not.
table. Oh, not for the create table. That's right. Yes, thank you.
So
not until the
for
load.
create table, as we discussed, all it does is creates the metadata entry in the Azure SQL. So it will be done pretty quickly because it's not running any MapReduce job.
Okay, thank you. So now that we have our table created, I can do a command called show tables. And this will show the tables that are stored within our metadata. And we have here a Hive sample table, which comes with the installation. And here's our new table definition. Now at this point, I just have the definition there. It's now time to load data in. So what I'm going to do is go back to my editor here and show you what a load statement looks like. Here what we're going to do is we're going to say load data in path and then specify the path where we have the data from our previous MapReduce job. So remember it's in Big Data Bootcamp job result, part 00000. And we're telling it to overwrite any data that may already be in the table in particular, and load it into the table working TE census info. So let's go ahead and copy that to the clipboard. And evaluate. Now I'm doing some MapReduce.
Actually, even now you are not doing any MapReduce.
Ah.
It's just copying file.
On a competitor's system, I've seen it do MapReduce, but we're about to do MapReduce now with the next select statement.
Finally.
Yeah, okay. So now we have our data loaded into the table. And so the next thing I'm going to do is let's just try a little select statement to see what's going on. So here what I'm going to do, let's just zoom in on this. I'm going to simply do a select star from our table, ordered by total population in descending order, and limit it to the first 100 records. Now this is one difference between Transact SQL, or one of several differences, is that Transact SQL uses a top clause with other SQL dialects, they use a limit clause. So we'll go ahead and see how this works.
Yeah, finally it's doing MapReduce. In fact, if you quickly switch to the job monitoring console.
I don't think I can go that fast.
Job
monitor console, job history?
Yeah, it
job
should
history.
Be showing running.
Yep, here it is.
Yeah, here it's running, see?
Yeah.
So it's now, when you actually do any kind of query, is when it's doing a job. And this results in not just one job, it results in multiple jobs. These are kind of chain jobs where, especially if you have a join or something complex, the input of one job fits into the next and so on. So this would have been very cumbersome to program by hand, where Hive did a lot of the heavy lifting from you and gave you that productivity.
Are we still working in the JIT world?
We are not.
Oh, we're still not. Okay, so
we are now in the Java
This is just, yeah, so we're just grinding away right now on the select statement here.
Right.
Let's see if we go back here. Job history, it says succeeded.
Yeah. So
okay, so now, unfortunately, I think my results are over in my Hive console.
Yeah.
So we get to run it again.
A little trick is that...
open a new window.
Yeah, have two windows side by side, and then you can do that.
Okay. So I get to run the select statement again.
So it will run that's the thing to notice. It will run the MapReduce job again. It's not because it has run once. It will. It won't run the next time. It will run the MapReduce job again, because if any of the new files have been added or new data has been added, obviously it wants to give you the latest and greatest.
So this is very different from SQL Server's data engine,
right,
where the query engine would actually keep track of the result set and see if nothing changed, it would immediately spit back the result here. But here we're actually running the MapReduce job over again and processing the data, groveling over all that data to get the result.
So that's why if any consultant tells you that you can replace SQL Server with Hive or vice versa, avoid him like a plague.
Yes, be afraid.
Be
very
afraid.
Yeah. Okay, let's take a look at our result now. So this looks interesting. So we asked it to look at the total population, and you know, I don't know about you, but in King County, where where Microsoft is, I know there's a lot more people than 9,999.
Right.
Right. And if we look at our results here, you'll see that the order just doesn't look right. You got 9999, we got 3 nines. Well, what's happened here is that we loaded in the population as text. Right. And so one of the ways that you can just verify that is you can see the information about your table by using a describe command. And what this describe command will go ahead and do is show you the table definition just to validate the results here. So this is going through the metadata, and you can see total population is string. Now that you realize it's string, the sort order makes perfect sense. It's just not what we expected, right? So let's go ahead and fix up the query a bit, because what I want to do is show you, very similar to Transact SQL, the cast command, which allows you to take a string value and change its data type, the resulting data type, to another data type, in this case, double. And so when we run this now, and go ahead and paste it in, it's re-executing the query, and this time changing the order by condition to be this calculated column, which will show the results hopefully the way we expect it to. So let's let this rip. Now the order by clause, I think I've seen the order by clause a lot of times. That actually does some reducing from the mapper.
Yeah, obviously.
Yeah.
So the other aspect is that for really small jobs, we are doing this on a small text file. And you might wonder, hey, on SQL Server, this will take me a fraction of a second, right? The file of this size. And that's true because SQL Server has indexes, its query engine is optimized to do this kind of queries. Whereas in this case, in Hadoop, we are scanning the raw text file. And not just that, starting up all those processes across all those machines has an overhead. So Hadoop bits or bits SQL, if the file is super large and your query is arbitrary, you don't know what you're going to query, and it just can't be fit in a single system. But if you have an optimized data set which is structured and you know the queries that you want to optimize for, SQL is going to win every single time. So that's the kind of the choice you have. A lot of organizations, what they do is they put their raw data, this kind of unstructured data, in Azure Blob Store and then run Hive queries to figure out what's the value of that data. Once they figure out what's the value of that data, then they use something like Scoop. Scoop is essentially the capability where you can in parallel move data between Hadoop and a SQL Server or two Hadoop clusters. So what that lets you do is you can then extract the useful information from Hadoop and stage it into Azure SQL. And then Azure SQL has all the cool stuff like indexes. Whoever thought indexes were cool, right?
Yeah.
And then you can have your queries responding to you super fast, right? You don't have to wait for all the things to spin up on all this machines.
Yeah. The big advantage that I've seen with Hive is literally groveling over lots and lots of data. I can't gigabytes and
Groveling
terabytes
is a
and all that.
technical term, right?
Yeah, groveling over, yeah. And one of the things that I didn't show here was the ability to actually create a partition on that data. So for example, I could have partitioned this data based on state. And so if I'm doing queries against state, the data can, my results can come back a lot faster because each state is essentially in a file or a set of files. In addition, you can break that down even farther into what are called buckets, which allows you, again, you typically would determine the number of buckets you'd use as part of the create table statement based on the number of clusters and processors that you have within that cluster, so essentially what you're doing is giving a bucket to each processor, and again within the partition, so you can get some optimizations there. And when you're talking about terabytes of data, the time that it would take to load that data into SQL Server to figure out what was going on, I could have written a Hive query to process that data at rest without having to load it in and get a result actually quite a bit faster than actually doing this double load. Mm-hmm. Okay, so if we look at the results now, back in our query, you'll see something that I would expect, like Los Angeles has a lot of people in it, or Los Angeles County. Likewise, Cook County in Illinois, you'd expect a lot of people there. And so by adding the cast statement, I'm able to put that calculation actually in the order by clause, which is something that normally you don't do in a transact SQL statement. But we've got our results as we expected. Okay, so that's using the cast command. The next thing I want to show is how you can actually use case statements. So very similar to transact SQL, we can actually do a case statement where we'd say, okay, let's output the state, the county, and the age group. And in addition to the age group, we're going to say when the age group is within our certain bounds, we're going to clump together even more folks. So age brackets between 10 and 19, we're going to call teenager. We have 20 through 39 adults, and so on. And so this will allow us to set up a case statement very similar to transact SQL. And what we do is we assign it our output value. You also notice that we're using an alias, TE, to make this all work. And so when you're doing a case statement, you need to make sure to include the alias in your definition, otherwise it will bark at you for the lack of, that's another technical term, right?
Seasoned citizen.
Seasoned citizen, yes.
I aspire to be a seasoned citizen someday.
Yes, as opposed to a senior citizen, yes. Okay, so let's go ahead and paste that in here and just show you what the results would look like. Not clear screen, that's I think. Okay, and again, we're doing, this is actually primarily a mapper because there's no order by clause or group by clause for the data. So most of the logic I know is in the mapping phase for this one.
Right.
Okay, so
yeah, that's the thing. Means most of the filtering you can do in a map-only job. Oftentimes, you'll hear this term as you go in the Hadoop land more and more, that there are map-only jobs. It doesn't mean there isn't a reducer, but the reducer is what we call identity reducer. Means whatever it's like an earthworm. Whatever gets in just goes out. It doesn't get transformed in any way. I'm sure in earthworm it does get transformed, but in identity reducers it doesn't. And the kind of things that you can do there is basic transformation or filtering. But anytime you have to do any kind of aggregation or joins, you need to use the reducer. That's where reducer does the heavy lifting after the mappers finish. The other thing to understand is, why do we often recommend that you need to have a homogeneous set of machines, not one machine which is 5 years old, one machine which is super fast. The reason is that because unless all the mappers finish, the reducers can't start. So there is a synchronization at the point of where all the mappers finish, right? Once all the mappers finish, only then can the shuffle happen and the reducers can kick off. So if your systems is unbalanced, then there is a possibility that it's the whole MapReduce job is waiting for the slowest machine. Of course, in the cloud, you don't have that problem because, again, most of the all the machines are the same or similar configuration. So pretty much you'll finish it on time.
Okay, so we've got our results back now. Let's take a look, and you can see how the age groups have now been mapped. So here's our set of teenagers, here's our adults, and so on, based on the grouping. So with the case statement, you can see we can do the substitution of information very similar to what you'd be able to do in Transact SQL. Now the natural thing for me to do is, at this point, if I'm going to be doing this query quite a bit, is I want to create a view, right? And so by creating a view, I get an abstraction on that statement, just like I can in Transact SQL. I simply wrapped the select statement with this create view statement here, and everything else is pretty much the same, right? So I'll go ahead and Control C and paste that in, and we'll go ahead and create our view.
You just did a clear screen.
Thank you. Evaluate. I would have been looking at that all
Now you know
day
how
long.
the clear screen works.
Yes.
So,
It's a very good command for just trying to figure out, I don't want to see any of that. Okay, so our create view came back pretty quick because it's just, again, creating a wrapper around the metadata. When I'm using tools like Hive for ODBC, actually these views look like tables, and so that's why I put an underscore name at the end of it right there. So now that I have my view, I can now go ahead and do my select statement against that view. So again, I'm just going to do the same kind of query. Now notice also that in this view definition, I casted the total population, recasted as total population. So now I expect that my result will look like I did after I added the cast statement on the order by clause. So we'll evaluate that. Now, there appears to be no performance advantage, really, of having a view instead of going directly against the table. I've been testing this in several different ways, and each time the numbers come back about the same. So it's mainly, again, kind of semantic sugar, sort of say, that you can encapsulate the logic around your select statement with the view so that it will run a little easier on your side, but in terms of the cluster itself, no real advantage there.
by the way, Bill, a fair warning. Don't get too attached to the interactive console because by the time we GA, we are expecting some dramatic changes. Get attached to the concepts because all these concepts we use here are going to still apply and be more important. But the UI, because this is a preview product, might change.
And funny you should mention that because I'm now going to show you why this console has its limitations and show you how you can get around those limitations by actually not only, right now we're running interactive SQL statements within this console, but you can actually run the statements as a file. So let me show you an example of that. That was a great lead-in, Sapdak. Back here, just to show, we got our results before we do the next step. So you see here, kind of get our same thing going here that we had before because we casted it as a double. In the output result, you're seeing the decimal point. Okay, so let's go back here. Actually, I want to do a join first before I show my little scenario, if you don't mind.
Please.
Okay, so what I'm going to do is that I used a case statement to do this logic to determine adult versus teenager versus seasoned citizen and all that. But as a database administrator or as a DBA, I personally like to do tables and joins to those tables. And so what I want to do is show you how you can quickly create a table with those age values, and we'll essentially join on the age group to show the output result rather than using the case statement. Okay, so let's get started. This one gets a little interesting here. So what we're going to do is we're going to go to here, and I'm going to take this data, which is this comma-separated data, copy that to the clipboard, and put it in our file here. And I'm going to save this file as age group details in our data directory. So go to our data directory, and we have our age group details file. Okay, now that I have that file, I'm going to go ahead and upload it to my to my storage directory. And the way I'm going to do that is I'm going to go back to our interactive console. Actually, I'm in our interactive console, so I'm just going to click on JavaScript, and now I'm going to do fs.put as a source file. Go back to our computer here and our D drive.
Again, if you were a real Hadoop person, you'd use a AZ copy.
AZ copy is a great command for doing these kinds of things, and that works great when you're in the interactive console. Allows you to upload information to here. But I'm working in the interactive console to avoid actually logging into the Hadoop cluster itself. You can actually log into the head node of the cluster, and then once you're in there, there's a Hadoop command shell, which I'm going to show later on when we go into the scoop session in day 2 of training,
right,
where we show off the scoop as we do some reporting services scenarios. And from there, you can do these commands that will easily allow you to copy from your local file system into your Hadoop cluster. So I'm going to go ahead and select my file, and for my destination, let's make sure I get my destination right, is I'm going to stick it in the root of our working container. Okay, so we have our file now uploaded. Next, what I'm going to do is I'm going to go back to my Java console, and I'm going to go ahead and create a table that is my age group info table. It has the age group as a string and the age group title. That's the value that we had previously in the case statement. Again, we're saying it's comma separated, and we're identifying our text file location for the table itself. This is not the data until we actually load the data. So I'll go ahead and copy this to the clipboard and go back to our Hive console. Hive. Okay, and we'll let that one rip. Okay, so we're done? Nope, not quite yet. So if I had the Hive metadata actually stored in SQL Server, which was that little option that I had early on to check with the cluster, I'm guessing this would have been a lot faster.
Yeah.
Yep.
Otherwise, it uses something called Derby.
Derby.
Yeah.
You're throwing a new one at me there, SopDoc. Derby, what's that?
It's a kind of a local, in-memory kind of something frivolous.
Okay, something that actually...
You won't want to use it in an enterprise.
No. Okay, so we have our table created, and now I need to load the data. So again, similar what we did before. We say load data in path, and we give it the name of the file. And I hope I added the txt at the end of the file. I'm going to do one little double check here, and go back to our JavaScript and do ls, just to make sure. Okay, it's there. Good. So we'll go ahead and copy in our load data command and evaluate that. So now we're populating our lookup table for our join statement with the data from the text file. Okay, so we have our data, and just to double check, let's do a quick select statement just to make sure. We hope it's quick, right?
Yeah, so when you're just doing a select, it's typically a map-only job.
Yeah.
It doesn't spend any time in the reducer, so it definitely is faster.
Yep. So you can see here, we've got our results as
Pretty
expected.
Yeah.
Yep. So now the join statement. So let me go and go back to my cheat sheet here. And so the join syntax looks very similar to transact SQL. Again, we put our select statements in here with our aliases as needed. We indicate the from table for the census file, and we're joining on our age group info table, giving it the alias AG. And then we use the on clause to specify that the age group equals the age group on both sides, and then limit the results. That's it for a join.
This will not only result in a complex reduce, but it will result in multiple jobs.
Yeah.
Wanna bet?
No, I know it does, because basically for everything that's doing the lookup, it's going out there and spinning them up.
I just wanted to win a bet.
No, no bet today. Okay, so we'll go ahead and let that rip. That could be why it's going to take a while.
Yeah, show them the job running.
Oh, you're going to make me do that, huh? Okay, so let's open up a new...
Just go back to that same place. Yeah,
Yep.
and right-click on the interactive console thing.
That one?
Yeah, and say open in new window.
New window. Okay, job history. Wow, that just is... There's one.
See, that's the one.
That's one job.
Yeah, just open it because it'll. You'll see there will be multiple phases.
I think it's still working through it.
Yeah.
Taking its time.
Yeah, they'll say reduce 100% complete, and again it will start off. So.
Yep. Well, it's already done.
Okay.
What happened to that window here? So let's go back here and
It succeeded.
Job
so it's
succeeded.
done. Yeah.
We see our output. Here's all the stuff.
Yeah. So.
Yeah. Okay, so here we had 2 mappers, 1 reducer. Looks like 1 job.
Okay. Yeah.
Oh well, should have bet. Okay, so we got the output that we wanted to see based on the join of the values. So that's pretty cool. So transact SQL, Hive joins, pretty much the same. Okay, what's next on the list? Where clause. Okay, I should point out that the online manual, I'm going to be brave here and browse to this, for Hive is out on the web under Apache Confluence, where you have all the syntax and everything like that, where you can learn more about what's going on. I should point out that we're using 0.09 as the Java or as the Hive version, and so the online manual actually has version information if things are not in the same version. So, for example, this join optimization command here is only available in 11, and so eventually, when we update our HDInsight Hadoop implementation with Hive and it goes to 11, we can get some join optimization working there. Okay.
And this is why we also let you the version of Hadoop that you want to work with.
Yeah.
So going forward, we will very soon update this with the new Hive. And if you have some dependency on the old Hive, you can choose the
choose the older version. That's great. Okay, so that is the manual. Okay, I'm going to do... again, the same kind of thing, but just show you the where clause. And the reason I do this is that this is just a little slightly off than what you would expect. So the join clause and the where condition are very temperamental in where you put those things. So transact SQL is a little less forgiving. But what I'm going to do here is I'm adding the clause where county equals Los Angeles just to show you there's data here that I'm going to come back with. So I'll go ahead and copy this to the clipboard, and we'll go ahead and run this query. Okay, so looking at Los Angeles, data, all been aggregated by age groups. So we just have them all grouped by infants and teenagers and things like that. So it shouldn't get too many rows back, but it wants to crank. Fortunately, nothing takes longer than 45 seconds, so we just have to blather on to kind of entertain you all. So hopefully this shouldn't take too much longer. Got anything else to add?
The geeky, awkward silence.
The geeky, awkward silence, yes.
Okay.
Okay, so we're getting there. So what was that little trick again? You went over here, right-clicked on that, said open new window, went to the job history. We've got our new job. It says running.
Yeah.
And we scroll down. Still don't have any output yet, so it's still thinking away here. Okay, so we're back now, and we've got our Los Angeles data. Now, what I want to do is show you that we'll go ahead and close that window at this point. And I'm going to do, okay, I'm going to show you the issue, one of the issues that Sapdak was talking about when running commands within the Hive console. Because literally, I hope that by showing you this example, I save you at least 3 hours of time from, if you look at me to this point, I've had hair. Or I used to have hair before I started this exercise. And since then, trying to diagnose this problem, I pretty much, whatever hair I had is all gone now. So what I did is I said, down here, we said, take our county like LOS, and so we should get Los Alamitos, Los Angeles, all those loses in our list. Okay, and because we saw Los Angeles is there, so we'll go ahead and evaluate, and let's see what happens. Care to guess how many rows we'll get back?
How many?
How many?
Well, I haven't run the query.
You haven't run the query, I have. Well, you'll find out here in probably, hopefully less than 51.694 seconds. That's how long it took to run the last one, looking for Los Angeles. So let's see how things go here. Okay, little dots are...
Now, if you had partitioned by the city or something, it would have gone much faster. Then it wouldn't have had to look for all the data on all the shards across the cluster. It could have just gone to the partition where the data is and got it. You can also bucket by time, so that's the other aspect. You might not. Most organizations, they don't want to run the query of all the data since eternity. They just want to do it on last 3 months or whatever, right?
Yep. And so partitioning, keeping the data around that way is a great idea. Well, we can see here that it took 33.7 seconds to come back with no data. Okay. Care to guess a hint here? Notice when I zoom in here at Los, our query looked like this, right? But now, when you look over here and what the MapReduce program did, notice no percent.
Because it's a delimiter.
Because the delimiter is a percent delimiter, or the percent is a delimiter within JavaScript in the console and the way the API is written, or the way the UI is written, that essentially it ate the percent. So, how do you do a like query?
You should try %%.
I tried %%, I tried /%, I tried you name it. There wasn't a percent I didn't try.
Okay.
And %, both of them got stripped out very nicely.
Well, you just saw a bug. We'll fix it.
Well, you said the console's going away, so. Okay, how do we fix this? Well, guess what? The way we're going to do this is we're going to take that same query and create a little data file with that query. So what I'm going to do is go back to my little editor here and say new, paste in the query, and I'm going to save this as, hit the save. I'll put it in the data directory. I'll call it HiveQL. let's just call it hive.text. Doesn't really matter what it's. Okay, so I have my Hive text file, and what I need to do is now go back here, and what I'm going to do is I'm going to upload it to my cluster in a destination called sample, and then hive.text. I should call it hive. Or query.ql. So let me fix that up here. Data. No, we'll keep it at hive.text. Okay, so go ahead and go back to my interactive console. Nope. Go to JavaScript. There we go. fsput. And we'll go ahead and browse to our Hive text file. And then for the destination, I'm using wax sample query.hql. Okay. So now I have my data. Now, one of the things I should point out is that when I issued the query like this, it's actually, because I didn't put the whole ASV path in here, what's happening is it's using the default storage container, Hadoop root, and actually using the sample folder within that to put our query file. So now it's time to go ahead and run the query. The way I'll do that is through this hive.exec file and give it the name of the file. Okay, and so if I go ahead and select this, and now I'm running this from the interactive JavaScript console to run the Hive program. And let her rip. Now it's created this view log link where if I go ahead and open this up in a new window, this is actually going to show me the end result of the query within this log file when all is said and done.
It's basically the std out that you're looking at.
Yeah, it's looking at the standard out device that it's showing the information on. Right. And so...
Actually, it is showing stderr. Std out is what you're going to show.
Oh, yes, yes. Right.
stderr is what you're seeing.
Okay. Now, so we're actually seeing all the gory details of the MapReduce action as it's occurring. So if we flip back here, you'll see everything that you would normally see if you were running this from the Hadoop console when you log in to the master node. Mm-hmm. And so our mapper and our reducer are 100%, and here's our data, mm-hmm. right? Just like that. We have our Los Angeles, Los Alamitos, and so we got our losses, which is really good. Okay, so with this example, I showed you how you can take a select statement, and it can actually be multiple select statements. As long as they're all semicolon delimited, you can put as many select statements into that file as you want. Then when you upload it and then run it with the execute Hive function, it'll go ahead and run those statements and show them in the output that you saw on the web page here. So that is how you can work around the dreaded percent.
Awesome.
So anytime you need to use percent.
And not just that, even if you want to save something and not do it interactively, you have a long series of statements,
Yep.
HQL statements. That's the way to do it.
Yeah, that's a way to do it, and we're actually going to show in the next module how you can do a series of statements with create table and loading data, and also doing select statements from .NET.
Awesome.
Rather than from this interactive console. Okay, so we've shown off the like clause. Let's do a quick example, show you how the group by query works within our screen here. So if I go ahead and zoom in, again, group by queries work very similar to the way you'd see in Transact SQL. We just say group by the columns that you'd have, state, county, age, and essentially you can let that rip. Now, while this one's running, let me go ahead and get this going here in our Hive console. I have a little note there to remind me is that in most SQL languages, you can, in the order by clause, give the column number as the order condition for your select statement. So for example, you'd say order by 1, order by 2, order by 1, comma 2. Within HiveQL, you have to use a column name. But if you notice here, as part of my output, or as part of my select statement here, you see here I've defined sum of total population as sum underscore pop. And I can just simply reference sum underscore pop as part of my order by clause there. So I don't have to, and many times I would have said, okay, order by 1, 2, 3, 4, and let that run. But you can't take that shortcut with Hive. You have to put the column alias in there for the order by clause.
Awesome.
Okay, so that one is cranking away just to show you what a group by result looks like. We're about to jump back to the slides.
Okay, awesome.
You want to wait?
No, let's jump back to the slides.
Let's jump back to the slides, and we can show the result when we get back.
Yeah.
Okay, great.
Anyway, we are tired of seeing,
Little da 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 da
yeah.
yeah.
Or results in just text.
Results in text. Yeah, we've got to show something in Excel, I think now. Okay.
Okay, back to the slides. So we are going to talk about the Hive ODBC driver. Now, Hive ODBC driver is kind of very similar to any other ODBC driver that you have seen. So from your application perspective, there is not much to do differently, except that you need to obviously use Hive queries and not native T-SQL queries, because it is at the end of the day going to the Hive processor to query engine to be processed. So here what we see is that it lets you do things like, if you have a Power Pivot model and you want to grab data from a Hive table, now the Hive ODBC driver is very convenient to create that query and use the DSN which is connected to the Hive ODBC driver to get that data. Now let's look at it working.
Okay,
Yeah?
sure. Okay, let's dig right in. So what I'm going to do is first I want to show you, hey, the group by query did work.
Okay.
So we got our results there. Okay, so what we want to do as part of this exercise, now I've already done some of it already, is that to get the Hive ODBC driver, you actually need to download it because it's not part of your normal Windows installation. To download it, you're going to go to the Downloads folder, or click on that, and you'll see two links, which are basically one and the same. You want to download the ODBC driver that matches your setup. And so you'll simply, in the case I have here, I have a 64-bit driver. You'll go ahead and download, and again, you get the kind of the same link here. You'll go ahead and select, hit Next, and this will go ahead and start the download process. Now, I've already installed the driver, so it would fail if I tried to run it right now. But what I want to do is show you how you would essentially configure it for Hive. And so to do that, you need to go to your ODBC data. ODBC, we go to our apps and set up ODBC data sources. And what you do is you'll say add, and after the install, you'll have the Hive ODBC driver relevant for your situation here. So you go ahead and select your ODBC driver. You'll give it a name, such as Big Data Jumpstart. You can give it a description, and you need to put in your cluster name here. So we have our cluster name. At this point, you can put in your credentials for your cluster, but it's not actually saving them anywhere. But clicking OK will validate at least that it's there. So now I have my ODBC user DSN set up that I can now use to import data into Excel. So I'll go ahead and click OK there. And now I'll go into Excel. What can you say about Excel? It does everything.
It does
right?
it.
In fact, one of the best definitions I heard of big data is that which crashes Excel. Unfortunately, the guy who said that probably didn't have the 64-bit version of Excel with Power Pivot and Power Query where you can handle lots of data. So,
in fact, I was in a panel in Silicon Valley, and one of the other panelists made that comment. So I said, "You must be using your mom's Excel."
Of course, yes.
So,
yep. Okay, so what we're going to do now is I'm going to go ahead and show you how to use ODBC to load in the data. So let's begin. I'm going to go over here in Excel and bring up my data tab. And similar to connecting to any other ODBC source that's not SQL Server, you'll use the data connection wizard. And then from here, you'll select the ODBC DSN. Hit next. And we see our DSN, our data source name here for our Hive cluster. I'll hit next. And again, I get all my basic information. And at this point, I definitely want to put in my credentials. Because what's going to happen now is it's going to go off and query our HDInsight cluster to see what tables are actually in the Hive data warehouse and in the structure. So we should see the Hive sample and our working files that we had. So if we go back now to our display, you'll see in our connection wizard, here's the Hive sample file. Here's our CS file, or our original one that we created based on our MapReduce. We have a view file that shows up as a virtual view, and then we have our external table. That was a small age group table. So to load in our table, I'll go ahead and select the particular one right here, right there, and go ahead and hit next. This is information that's needed for actually having Excel connect up with the driver and create our ODC file, which will keep track of things. I'll go ahead and just finish this up and tell it to paste it into our existing worksheet. Now at this point, it's prompting us again because it's making another round trip to the back end to load in the data. Now you can see at the bottom of Excel, it says waiting for the query to be executed. So it's actually going out now and in the background running the query.
there.
And voila, there's our results.
Awesome.
It's
awesome.
just like stunning, right?
Stunning.
If I'd specified the view, I would have gotten total population actually as a numeric value. That would have been cool.
So here, just to be clear, what Bill just showed is that you have, say, tens of terabytes or hundreds of terabytes of data sitting on Hadoop cluster. Then you have created a schema on top of that raw data. Those raw data can be, text file. And in Hive, you can use regular expressions to figure out even columns on just any data, essentially, any text data. You can also create other kind of UDFs or serializer, deserializers to do this on custom data types. And once you have done that, you can now do all your analytics from Excel against that big data. So when I said that it's no longer true that you cannot do big data from Excel, this Bill just proved it.
Yeah, I'm
right?
gonna take that one step further. So I'm gonna show you kind of, we used Hive, which is one way to access data, and that works really well. I think assuming your Hadoop cluster is up and running.
Absolutely.
Remember we talked about, or SAPDAC's been talking about, hey, what if you could create your Hadoop or your HDInsight cluster, run your Hive job, save the results out there, and then kill the cluster off, right? Well, if you do that, Hive doesn't work. There's this thing called Scoop, that doesn't work. But your data's there on Azure Blob Store, right?
Yep.
And so one of the things we can do is actually use Power Query to go after that data and load it into Excel as well. So let's give this a whirl here. Now this is the first time I've hooked up Power Query or tried Power Query against the data. But what I'm going to do here is, in fact, I'll just create a new worksheet here so we don't confuse things. By going to the Power Query menu, you'll see it looks very similar to the Data tab, except when you drop down your list of data sources here, we can actually select from a Windows Azure HDInsight location. And so when I select that, what it's going to do is ask me for my account name. So this is BD Jumpstart. And this is the blob store, not the actual cluster name. It just so happens they're one and the same. And then it's asking for the account key. SAPDAC, you said not to memorize that key.
You have that. I know you have that.
I've got
in
it
your
somewhere.
cheat sheet.
I know it's somewhere. It's in my. Well, yeah, maybe.
It's pasted right on top of your cheat sheet.
Yeah.
Watch module 1.
There, watch module 1. So back in module 1, we actually went into our HDInsight cluster, went to the storage node, and selected manage key to bring up the little dialog. Now, I happen to keep this around prior in my file, so let's go ahead and use that. So we'll cut back over to the demo machine now, and I've got my storage key, and we'll go ahead and paste that in here. So, whew, saved a step here. Let's hope.
Right.
Okay, now that we're connected, we bring up the query editor. Now I can go ahead and right-click and rename this, and we can call it our census table. When I select, what you see here are actually my containers. So Hadoop root is the default container for my information. We also have our working directory. Now in our working directory, we had, let's see if I can scroll over here. We have our...
Oh, the part 00 thing.
That's the one right there. The way we can validate it is it's in the right path over here. So we can see our full path.
In fact, you can actually filter on the folder name by the little text that you...
Oh, yeah.
Yeah.
Yeah, but I'm not going to show that off right now.
Okay.
I know that's the file I want right there, though.
Yeah.
So I'm going to go ahead and select this, and this was the file, or this was the Hive table that's comma separated, and you can see here that I got one column. Well, that doesn't do me any good. I have 4 columns. Well, let's see. Power Query to the rescue. So what I'm going to do is say split column by delimiter, and say comma separated.
I'll be
Boom.
honest, Bill. Power Query is so much fun. I'm feeling like grabbing the mouse off your hand and doing the demo.
Yeah, okay. Okay, the other cool thing that you can do is you can go ahead and change the type here to be numeric, and so now that would behave correctly. And I could go ahead and rename the columns, but I'm not going to bother with any of that. Right. But one of the things you can also do is actually go in and set a text filter. And so here, if I set a text filter on that data, I don't have to bring it all down when I do the query. So I can say equals Washington, and we can go ahead, click OK, and this will go ahead and filter out the Washington data right here.
Right.
Now, on the far right side here are these steps. And each one of these steps represents an action that I performed. And so if I didn't like the change type, I could delete it. If I didn't like the filter, I could delete it.
It's sneaky. It's actually writing a program behind my back.
Yeah.
And then it actually does it on a sample of the data.
Yep.
Once you click that right green button.
That one right there?
Yeah. It will actually run the program on the entire data.
Yeah, so now it's running it, but it's going ahead and filtering the data on Washington at this point.
Exactly.
And so just like that, importing static data on my HDInsight cluster. So, that's it.
So, back to the slides. What we just saw is, first of all, we saw a lot about Hive, how to create a schema with Hive, how to query Hive, different operations within Hive. Not only that, then we consume that data from traditional application like, for example, Power Pivot or analysis services or other third-party applications using the Hive ODBC driver. And then finally, we also saw how to use Power Query to get that data even when you don't have a cluster. You just have the results of your job stored on the Azure Blob Store. That means you're no longer paying for the cluster. You can still go against the Blob Store directly and pick up all that data and query against that using Power Query. And once you have it in Power Query, you have shaped it to the way in the way that you want it. Then you can plug it back into Power Pivot or any other Excel analytics that you want to. So with that, we have our next module coming up in a few minutes, and stay tuned.
Yep.
Thank you.
Thank you.